back to another video. So today we're going to be going over the Java Explorer Oracle certification and the course for it. So I'll be going over module 1 today, and let's just get straight into it. Okay, so let's start off with lesson 1, which is Java Origins and Ecosystems. So let's start off with an introduction of Java. Java was created by Sun Microsystems in 1995 as a general use programming language based on C and C++. It was mainly used for consumer electronics in the beginning. So, Java is an object-oriented and platform-independent language, which I'll be explaining later on in the video. So, modern Java is used for the Internet of Things, cloud computing, and other things on billions of devices today. So let's quickly look at the Java ecosystem. So first up, we have Java Card, which is usually used on SIM cards. Java ME, which is used on, Java ME, which stands for Java Micro Edition, and that's used on smart TVs, set-top boxes, and other devices. Java SE, which is Java Standard Edition, which is just a standard edition of Java. Java MP, which is Java Micro Profile, used for microservices, which means sending info to a server for how your application should run, and other things like that. And Java EE, which is Java Enterprise Edition, which is Java specifically used in a corporate setting. So web services, messages, Java Beans for sharing code, user interfaces, creating reusable and shareable code which can run on multiple types of devices. Okay, so how does Java cross-platform work? So like I said before, Java is cross-platform, and this is because you only need to write and compile code once for it to work on all devices. Computers don't recognize English code, so codes that we create must be converted into a basic language that a computer can read. This is called machine code, and the process of converting your written code into machine code is called compiling. Now, most languages require you to write your code, compile it for your computer, and then run it. So the process would be code, compile, run. However, Java makes you convert your code into bytecode first, and this bytecode can then be used on any device or platform. So then the process would be code to bytecode to compile and then run. So this is better because let's say, for example, you write your code on your Mac and then compile it and send it to a Windows PC. Because the code was sent in its bytecode form, it will not require any efforts on the Windows user's end to open up the file and then use the code that was sent to them. Or else in other cases, the Windows user would have needed to compile the file first. Java programs are executed on a JVM, which is a Java virtual machine, which emulates the hardware of the computer that the code is running on and translates the bytecode into executable code to then be run. This is why you can hear the saying, write once, run anywhere, when talking about Java. Okay, lesson 2, which is Java language. So Java has 3 basic code structures. The first one is class, second one is package, and third one is module. So a class is a basic unit of code, which describes the data and logic of your program. A package is an intermediate logical code aggregation, which in simple terms just means a group of 0 or more classes combined. So for example, let's say you had an order entry app. Your package would be the entire order entry system, while your classes would be the individual items that you can order, or maybe the delivery method that you want to choose, and other things like that. And then module is a high-level logical code aggregation, which just means a group of packages combined. So this feature was introduced in Java SE 9, and this controls which parts of your code you want other people to be able to access when it's shared. Okay, so let's look at some Java syntax. The code starts off in this example by defining a package, and then a class is created, and inside of that class are methods. These are the setSalary and getName methods. And last are the variables, which store information such as the string variable name with the string meaning text, and the second one is a float variable salary, with the float meaning a decimal number. So first the name is set, and then later when the getName method is used, whatever the value is stored in the name variable is then shown to the user. Also, the setSalary method works by setting the salary variable to be the same as another variable called value. Okay, so now let's look at an example of checking over your code and error exceptions. So in this example here, a readLines method was used, but it didn't work properly. Instead of the program crashing or having to create a long error message, exception handling is used, and in this case it just tells the program to skip over this line in the code. And most modern programming languages have exception handling. Okay, lesson 3, Java design. So let's go over classes and objects first. So classes represent a type of thing, while objects are a specific version of that thing. For example, let's take computer mice. Overall, the class would just be computer mice, but when a program is running and an object is needed, this class of mice would then be turned into specific objects, such as let's say a Razer Death Adder, or maybe a Logitech G502. Okay, so what's inheritance? Inheritance is when you have multiple levels of classes that pass on traits from an upper level to a lower level. So to explain this, let's say you have a general class of animals. All animals have common attributes of having heights and having weights, and all animals also have behaviors of wanting to eat and sleep. So now let's say you split this up even more and wanted to create a dog class and a fish class in the class of animals. So they share the same attributes of having names and weights, and of having heights and weights, and also share the behavior of needing to eat and sleep. However, dogs eat different things than fishes do, so the way that the eating behavior is applied is different with dogs than it is with fish. So during the runtime, each object is analyzed and given the behaviors that it corresponds to. And the ability of Java to give different objects their corresponding behaviors is called polymorphism. Also, more attributes and behaviors can be added to lower level classes as well, such as dogs wanting to chase cars or chew bones. So, flexible design. Java uses other ways to organize classes and objects too. It uses interfaces to abstract out common behavior among classes. It uses enumerations, also called enums, to create user-defined constants. And it also uses generics, which gives specific type information to the compiler, making running code easier. So in the example, this enumeration makes sure that when being fed food, the correct type of food is given to fish and dogs. And then in this example, a list is created of pet objects, and this list passes on generic information to all items in the list. If you try to add an object that's not part of the pet's interface, such as let's say a pen, then that won't work and the program will give you a warning. Okay, so analysis, design, and architecture. UML, also known as Unified Modeling Language, is used to create an overall layout of all the requirements a program will have, a model of the overall code structure, and a description of how the applications will be deployed. And this is done through diagrams that visually convey the required information. So as you can see, each of the diagrams shown has a different purpose, whether it's to model how the user interface will work, or describe the structure of all the classes that are present in the program, or how the program will realistically be deployed. All of them are important to have in the planning stage of an application. Lesson 4, Java APIs. So Java arrays and collections. So an API is an application programming interface, and this is a common chunk of code that's already pre-made to just have to be implemented in your code so that you don't waste time writing out all the lines of code for something very common. And an array is a simple group of 0 or more elements. A collection API helps the user by providing easy commands to add items, remove items, or change the order of the items in an array. Okay, let's look at Java Stream APIs. Java Stream APIs filter, map, and reduce large streams of data, and they perform expressions on data using lambda expressions, which are a form of functional programming. So as you can see in this example, a new list is created from an already present list of employees, and for this new list, a Stream API is used to filter out employees who make less than 1,000. And for each of these employees who remains after the filtering, a bonus is calculated. Okay, so what are Java I/O APIs? Input-output APIs focus on using input files such as .text, reading these files, and then making some sort of changes to the file and outputting it again. So in this example, the file destination of an employee text file is turned into an object, which can then be manipulated by the code, and in this case, the file called readme is being read, and the lines on that file are being written word for word in UTF-8 format onto the employee text file. Java Concurrency APIs. Concurrency API will maximize efficiency by adapting the exact amount of cores that a user's CPU has to get the most performance out of these cores. Java Persistence API. This is pretty complicated stuff, but to summarize, it basically uses JDBC, which is Java Database Connectivity Protocol, to move data from a Java program into a database and from a database back into Java. So, Lesson 5, Java and Enterprise. Implement web services with Java. So Java is mostly used in enterprise in the present day for back-end processing, as it's not used so much for user interfaces anymore. Web services are commonly made using Java, and web services are used to bring data into the enterprise, then have them repurposed and used in a standardized manner. Basically, it's sending data over to the enterprise using HTTP ports, although some web services such as SOAP can use any transport, but it's typically over the internet. The JAXB and JAXP APIs allow Java objects to be converted into XML for corporate use, or from XML back into Java. And the same thing also works with JSON, which is JavaScript Object Notation. The JAXWS API can be used to enable SOAP service implementation and define specific types of interfaces and methods. And the JAXRS API uses REST API and can be used to leverage HTTP transport and operations available in HTTP. SOAP only works with XML, and while REST works with all types of data. Enterprise Java versus Standard Edition. So Java Enterprise Edition applications are deployed to an external server to execute, unlike Standard Edition, which uses a command line on the user's PC. So these servers provide support for Enterprise Java beans, known as AJB, and web containers. Using this container system provides security, concurrency, transaction management, and a bunch of other services. OCI specifically, which are Oracle's cloud infrastructure, provides a bunch of APIs and services which help support enterprise applications. And so all of that covers Module 1 of the Java Explorer program, and I'll see you in the next video with the next module.